Hello, today I'm going to discuss linear harmonic oscillator. Uh, this is another method, operator method. The last class we discussed about this linear harmonic oscillator by using polynomial method or another name of that polynomial method, Schrodinger method. So now we are going to discuss linear harmonic oscillator, the operator method. Okay, the operator method of solving for the energy eigenvalues of a linear harmonic oscillator is based on the basic commutation relation. We know X, P, the basic commutation relations are I, H cross, where X and P are the coordinate and momentum operator. The Hamiltonian of a linear harmonic oscillator is H equal to P square divided by 2m plus 1 divided by 2 m omega square x square. So now it is convenient to introduce two new operators A and A dagger. So these are defined by like this. So A, I'm going to write this one m omega divided by 2h cross whole power 1 divided by 2 into x plus I 1 divided by 2m h cross omega whole power 1 divided by 2 into p. In a similar manner, A dagger I'm going to define like this m omega divided by 2h cross whole power 1 divided by 2 x minus I 1 divided by 2m h cross omega whole power 1 divided by 2 into p. So these are the new operators. The A we can define like this. A dagger we can define like the proof is there. So if you want to prove this, then I can give you one more lecture by solving this A dagger proof. Okay. So here I'm going to do one simple operation in simple multiplication. I want to multiply these two operators. First, here I'm going to multiply A dagger. So that equal to, so in case if you try to multiply this thing, two things, this is m omega divided by 2h cross into x square plus I want to multiply this thing into this term m omega divided by 2h cross whole power 1 divided by 20x remaining into the minus I. Okay, here minus I is there, 1 divided by 2 m omega h cross whole power 1 divided by 2 into p plus this term into this term I into 1 divided by 2m h cross omega whole power 1 divided by 2 into p into m omega divided by 2h cross whole power 1 divided by 2 into x plus I into I square and minus 1 plus 1 divided by 2m omega h cross remainder p square. Okay, this is the simple multiplication. So in case if I try to cancel this, this one cancel and this one cancel, here also 2m will cancel, this one also cancel. The remaining parameter is like this. A dagger equal to m omega divided by 2h cross into x squared plus, so I'm going to write this term first, 1 divided by 2m omega h cross whole power, sorry, p squared plus, here minus is there, here plus is there, so remaining thing I 2h cross, okay, here also 2h cross is there, I also there here, then I can write like this, I divided by 2h cross by using these two terms, okay, the minus is there, that's good. This one is xp minus xp, this one is px, I didn't change any operator position, so here I multiplied in the order manner, there is no interchange their positions, okay. Yes, if you interchange their position and momentum operator, you can get some sign different, okay, px, right, okay. A dagger equal to omega divided by 2h cross to x square plus 1 divided by 2m omega h cross into p square plus I divided by 2h cross. This one is px, right? This one is p to x. What is p into x? What you can get p into x? I h cross, right? Minus, okay. X into p equal to I h cross. Px equal to minus I h cross. So therefore, this term m omega divided by 2h cross to x square plus 1 divided by 2m omega cross into p square plus I divided by 2h cross to minus I h cross. So this h cross cancel. I into I square this is 1 divided by 2. So this term I'm going to write like this. Please try to check this thing. Okay, here I'm going to write this one. Only this term. Hamiltonian h divided by h cross omega. You can write this term, these two terms like this. H we know kinetic energy plus potential energy. Then you can write this one h cross omega. So this is the Hamiltonian plus remaining term 1 divided by 2. A dagger. Okay. So similarly, in case if you try to multiply A, A dagger into A, then you can get definitely this h divided by h is Hamiltonian minus 1 divided by 2. Okay. So by using this equation, I'm going to tell one equation. The h equal to n plus 1 divided by 2 into h cross omega, where n equal to A dagger A. So this we can call the number operator or occupation operator. So this is very important information. Okay, so remember this one. Next, I'm going to do another operation, that is I'm going to add two results, A dagger plus A dagger A. That equal to I can get h divided by h cross omega plus 1 divided by 2 plus h divided by h cross omega minus 1 divided by 2. These two terms are cancelled. The remaining term I can get a dagger plus a dagger a equal to 2h divided by h cross omega. So from this equation, we can get h equal to h cross omega divided by 2. Simple, right? A dagger plus a dagger a. So I'm going to give this one box. We are going to use all these equations at the end of the eigenvalues and eigenfunctions production. Now I'm going to do another thing. Computational relations of a dagger. Okay. So a dagger minus a dagger a, right? A dagger, this is computation relations. So the product we know already, h divided by h cross omega plus 1 divided by 2 minus h divided by h cross omega minus into minus plus 1 divided by 2. Then we can get here one important information, a dagger equal to 1. Similarly, you can get a dagger a equal to minus 1. A dagger a equal to minus 1. So this is one more important equation. This is also one more important equation. Okay. Now I'm going to do one more computation relation, that is A into H computational relation. We know H, right? So we can express this one A H minus HA. So I'm using only H, Hamiltonian. So we already know Hamiltonian H cross omega divided by 2 to A dagger plus A dagger A. This is Hamiltonian. So we already know this one. A Hamiltonian H is equal to H cross omega divided by 2 A dagger plus A dagger. Right. A into H cross omega divided by 2 into A dagger plus A dagger A. Then minus H cross omega divided by 2 into A dagger plus A dagger A into A. So this H cross omega divided by 2 common, then A square, okay, plus A dagger plus A dagger A, this is first term, minus, I'm going to multiply order, okay, A dagger into A plus A dagger A into A dagger A, which means A square. So from this equation, these two terms are cancelled. The remaining term is h cross omega divided by 2 into a square A dagger minus A dagger A square. So we can write this equation like this, right? In terms of computation relation, the AB minus BA. A squared into A dagger not equal to h cross omega divided by 2. Then we can write this equation like this, A into A dagger plus A into A dagger to A, right? So therefore, h cross omega divided by 2, A, this one is 1, this one also 1, 1 plus 1 into A. So therefore, h cross omega divided by 2 into A plus A equal to 2A, right? 2 get cancelled, then h cross omega A. So A comma H, A comma H. I got h cross omega A. Similarly, in the same way, in case if you do like this, A dagger comma H commutation relations, A dagger H minus H A dagger. So then you can get this A dagger comma H equal to minus H cross omega A dagger. Remember, minus H cross omega A dagger. This is another important equation. Okay. So these properties are enough to calculate eigenvalues and eigenfunctions of linear harmonic oscillator. Okay. By using all these operators, I'm going to calculate eigenvalues and eigenfunctions of linear harmonic oscillator. So we already know this is a polynomial method, right? Last class we discussed this is linear harmonic oscillator, no operator method. Okay. To obtain the energy levels of oscillator, we have to calculate the matrix of the Hamiltonian and diagonalize it. However, if you work in the energy representation in which eigenvectors of Hamiltonian form basis of the space, the matrix of Hamiltonian could be diagonal. So what does that mean? So what I say that is, in case if you take Hamiltonian is applying on this energy state. This is operator, Hamiltonian operator. So what we can, by using eigenvalue equation, we can get eigenvalues here. Then the same function, I mean same wave function is repeated. This is eigenvalue equation, right? You remember when an operator O is applying on a wave function, if you get same wave function and multiply by some constant value, this type of equation is known as the eigenvalue equation. So similarly, in case if you apply, this is scalar, C means scalar, here energy is scalar, right? This Hamiltonian operator is applying on this wave function, then I got his scalar numbers in terms of n state. So in a similar way, I'm explaining this thing like this. M H into N equal to En only into M to N, right? This is example. This is eigenvalue equation general definition, right? So by using this equation, I'm going to write equation like this. Then we can write this equation M H into N equal to this equation I'm going to write in terms of chronicle delta function, delta M into N, where En is eigenvalues of nth state, right? Uh, En is eigenvalue of nth state. Next, we shall evaluate the matrix of product A and A dagger. Okay, I mean A dagger E. So please try to focus here. In case if I apply A dagger A, okay, on this state, on this state, same state I'm going to apply. This is also end state. This A diagram, we already know what is A product of A diagram in A. We know, right? See here. What is product of A diagram? A diagram A equal to H divided by H cross omega minus 1 divided by 2. So in place of this A diagram, so I'm using H divided by H cross omega minus 1 divided by 2. This is N, this is also N. This ket vector, this is bra vector. So we know eigenvalue equation, what we discussed the above just now. So H is applying on this energy state, this H is applying on this energy state, then we can get N. H is applying on this energy state, then we can get En state, and this is N state, same state, like that. Okay. If you apply this operator, this is constant, this is minus 1 by 2 constant, these are not up, only H is applying on this nth state, this is operator. Okay, this is wave function, this is operator, this is wave function. H is operate on this nth wave function, then we can get here En, right? See here, En divided by H cross omega minus 1 divided by 2 N into N. So this is 1, right? Psi star psi is equal to, the remaining equation here I got A diagonal A into N equal to En divided by H cross omega minus 1 divided by 2. In case if you don't know the quantum mechanical tools, I mean mathematical tools of quantum mechanics, operators and eigenvalues, eigenfunction equation, then please go and watch the one series is there, mathematical tools of quantum mechanics. There we can learn some basics and discuss much deeper basics, what we require, what we want to solve the quantum mechanical problems and quantum mechanical. That part on it is okay. So this similarly, in case see here, this is very important equation. This is equation number 1. From here onwards, I'm going to use equation numbers, and so here I'm going to do one more different thing. A diagonal A, I'm applying on this thing. So I can write this A diagonal A equation, like, in case if you aware of this type of equation. Observe clearly here. This is N into A diagonal, okay, into M. This is ket vector. This is bra vector. What is this product? 1, right? Then I can write again A into N diagonal. So observe carefully. This is 1. The remaining equation same, we can get this type of equation, right? So therefore, I'm going to express this total equation like this. This is M here, A into N. In case if I do here, diagonal, if I apply diagonal, then cat will change into bra will change into cat. Here I got A diagonal, right? A diagonal equal to A, right? So here I get the A diagonal value. So this equation I get. And remaining portion, this portion is there, right? I'm going to write as it is. I didn't do anything here. M A N. So what is this function? What is this operation? This is psi star. This is psi, right? Psi star psi modulus of psi square is always positive, right? So probability. So this we can represent it like this: M A N whole square. This is always greater than or equal to 0. This is always greater than or equal to 0. Hence, equation number 1. So here equation number 1 is there. From equation number 1, we can write En divided by h cross omega minus 1 divided by 2 greater than or equal to 0. Then En divided by h cross. Okay, why I am wasting the time. From this equation, En greater than or equal to 1 divided by 2 h cross omega. See here. This is ground state energy, right? Okay. Now consider the Eigenvalue equation. So what is Eigenvalue equation? We know, right? This is Eigenvalue equation. En operating from left side by operator A. This is operator A. I'm going to operate this operator A on left side of the equation. A H into N En into A into N. So we know already AH equal to HA plus H cross omega. We got this equation, right? A into H. What is that one? H cross omega, right? H cross omega A. From that, sorry, from this equation we can get AH equal. Then we can express this one into AH minus HA, right? HA is equal to H cross omega. Then easily you can get this one. Okay. So I'm going to use this AH here. AH here. Okay. HA plus H cross omega A, right, into N equal to En A N. Then I'm going to split this equation HA into N plus H cross omega A into N equal to En A into N. Then HA N equal to En minus H cross omega into A into H cross. So what we observed here, in case if you apply operator A on this quantum state, it will decrease by H cross omega, right? This is lowering operator. A is lowering operator. Okay. In case if you try to do similar equation, similar thing, similar procedure, okay, similar procedure, then you can get this one. H A dagger N equal to En plus H cross omega. A dagger into N. These two things are very important equation. If you apply A dagger on this state, it will increase by, because you apply H this nth state, what we get? H is applying on this state in eigenvalue equation, right? Then again I'm going to apply here, okay, here H A into N, then En minus H cross omega, okay. That is a important equation, very important. Like that you can get here the equation value. These two are operators. This is Hamiltonian operator. This is rising operator. This is lowering operator. The operators A dagger and A are respectively known as the rising and lowering operators. Okay. So A is rising operator. I mean A dagger is rising operator. A is lowering operator. Okay. And one more thing I'm going to explain here. It follows that the gets A dagger into nth wave function and A into nth wave functions are also eigenkets of H. The corresponding to the eigenvalues are, so these corresponding eigenvalues are En plus H cross omega. So the corresponding eigenvalues En minus H cross omega. Okay. Now I'm going to derive one more information. So denoting the ground state eigenkets corresponding to the minimum eigenvalues, it is E naught right by this is the ground state. So therefore we have an equation in case if you try to apply A on this ground state, we got E0 minus, you try better to write this equation first, A0, then this eigenvalues H cross omega minus also there, E minus H cross omega, E minus H cross omega. Okay. From this equation, I'm going to write like this, A into 0 equal to 0, right? So therefore, if you apply the A dagger to A equal to 0, remember these two equations. Therefore, we know the A dagger A value, then I'm going to write this equation like the H cross divided by H cross omega 1 divided by 2 into ground state equal to 0, right? Then if you apply this operator in ground state, this one, so you get E0, right, divided by H cross omega minus 1 divided by 2 equal to 0. Therefore, E naught equal to 1 divided by 2 H cross omega. This is ground state energy. Okay. When the eigenvalue equation we know H is applying on this quantum state. This is operator, this is eigen state. This is operator, this is eigen function, right? Wave function. Then we can get E0 to get function. Operating from the left by this equation, maybe it could be leads to, so H A dagger I'm going to apply on this state. Then what we get here, E0 plus H cross omega. A dagger into 0, right? So one state is increased, right? H cross omega state is going to increase. This is first step. Again, I'm going to apply again here A dagger. Okay, I'm going to apply A dagger again here. So A dagger on this state again. So we already know this thing. E0 plus H cross omega we got here and 0. Then we can get 3 divided by 2 H cross omega. Okay. Then we can apply A dagger into A dagger again one more time. So in case if we try to increase these dagger values, plus 2 H cross omega, 2 H cross omega into 0. So we already know E not equal to 1 divided by 2 H cross omega. Then I'm going to try to add this thing, right? Because if you apply A dagger on this ground state, it will increase it by the one state. Again, I'm going to apply A dagger operator on this ground state. It will increase it by the another state. Here already one state is there. This is second state. Okay, 2 H cross omega, two operators are there. Then we can get resultant value is equal to here 5 divided by 2 H cross omega, right? Like that, we can get easily nth state wave function, nth state eigenvalue function. If you apply A dagger into n times on this ground state, then we can get here the E naught plus n H cross omega into ground state. Therefore, we can write this equation like this: n plus 1 divided by 2 is better to write here and so on. H cross omega ground state. These are the eigenvalues of harmonic oscillator. The eigenvalue of a harmonic oscillator you can get easily by using this operator without using any integration up to here. So now I'm going to try to calculate eigenfunction of this linear harmonic oscillator. It is already reached time 50 minutes. It will take one more 10 minutes to complete this eigenfunction. Okay, don't waste time. Let's go finish this thing first. Okay, we know A operator A is applying on this ground state, we can get 0, right? So I know two operators. One is lowering operator and rising operator. M omega divided by 2h cross 1 divided by 2x plus I into 1 divided by 2m h cross omega into p whole power 1 divided by 2. So this equation I'm going to express like this: just 1 divided by 2 m omega h cross I'm going to get common. Okay, these two terms. Then you can get here m omega x plus h cross d by dx. You try to multiply this thing, then you can get here. Okay, so this is A operator A, right? I'm going to use this operator A here. In place of A, I'm going to use this operator. Okay, so please listen carefully. 1 divided by 2m omega h cross whole power 1 divided by 2 m omega x plus h cross d by dx into this state, right, equal to 0. So what is this state? What is this state? How we can write this state? Psi naught, right? So I'm going to use this function psi naught for our coordinate. Okay, psi naught. So then this term is going to 0. Then remaining term m omega plus h cross d by dx into wave function psi equal to 0. In case if you try to use something different here, minus m omega x x wave function psi equal to h cross d by dx into wave function sin. Okay, no problem. This is sin. So this equation, I'm going to interchange this term here and this dx here. Okay, only dx. Then we can get minus m omega x into dx and h cross also. This h cross I'm going to uh, using here denominator. Okay, divided by h cross equal to d psi naught. Only this divided by psi naught. We know this one is log f of x, f dash f of x by log f of x. Then we can integral. In case if you try to take integration here both sides, okay, then we can get this is log x. Okay, log psi naught equal to log c some constant plus minus m omega. This is x square divided by h. All right. Okay. So therefore, I'm going to write this constant term like this. So from this equation, psi naught equal to is exponential. Then I can use this term as n naught e power minus m omega x square divided by h cross. We have already seen that this type of equation. Yes, if you apply a dagger on this quantum state, then what we get here is second one state you can get right here. This one state, right? In this way, I'm going to write this one here. This one, right? So from this equation, I'm going to write this equation like this. So if you apply a dagger on this quantum state, it will increase by one state like this. These two equations are similar. So therefore, I'm going to define now first state wave function. So therefore, psi 1 equal to n1 m omega x minus h cross d by dx e power minus m omega x square divided by h cross square. Yeah, the two I forgot. Okay, x square divided by 2, right? 2 I forgot here, sorry. Okay, this is not square, 2 here. Yeah, right, 2. So repeatedly operating by a dagger from left side, we can get the nth state, right? So psi n psi n m omega x minus h cross d by dx to whole power n nth times e power minus m omega x square divided by 2 h cross. This is nth state eigenfunction of harmonic oscillator. So we know now. I'm going to tell you one important information here. A and A diagram, one is rising, A dagger is rising operator and lowering operator. Then we can call these things the another name annihilation operator, creation operator. A very important thing. These are the final equations we got. En minus h cross omega A into n. One more. A dagger, if you apply on nth state, it will rise by the nth state. Okay, A dagger into nth state. So here A we can call lowering operator or annihilation operator. N I H I L A T E S annihilate operator. Or we can call this one destruction or destroy operator. A dagger we can call some another name creation operator. Okay. So therefore, we can call these terms creation operators and annihilation operators. These are very important operators, quantum mechanics, especially in the quantum theory of electromagnetic field. Annihilation operator, creation operators are very, very important. So this is all about operator method. So without using much difficult integration values, then we can easily derive these eigenvalues and harmonic oscillator. So it will take very long time, maybe 1 hour or 1 hour 10 minutes to derive this thing. So in examination, we can derive within 30 minutes, 20 minutes because of this class. So it will take too much time. Okay, for explanation, everything. Don't worry about this. So you can get easily. This is linear harmonic oscillators. First, I designed two important operators. One is rising operator, lowering operator. This lowering operator we can call annihilation operator. This is creation operator. So remember these two equations, very important. Frequently, I'm going to use the two operators. This is how the annihilation and creation are work.